Okay, let's look at combinations of functions. Now, let me show you what I'm talking about. Let's suppose we have a couple of functions here, f and g, and we want to combine them in various ways. Now, a lot of this is just really notation. In other words, if we want to talk about f plus g of x, this right here, well, what does that mean? That means f of x plus g of x. So if you see this, if you see two functions, f of x, g of x, and you see this f plus g of x, what that means is take the f of x right here and put it together with the g of x. And of course, we could just add like terms. See, 5x and 2x, that's 7x. 3 minus 4 is negative 1. And likewise, if we have f minus g of x, of course, that means f of x minus g of x. Now, you got to be careful always in mathematics. When you have negative numbers, when you have minus signs, that tells you proceed with caution. And in particular here, notice we have f of x, 2x plus 3, minus, in parentheses, we have 5x minus 4. So you have to be careful to put the whole thing in parentheses. Because if you don't, you would end up getting the wrong result, because you would end up having minus 5x minus 4, but in reality, this minus and this minus make a plus. So if you work this out, you would get 2x minus 5x, negative 3x. 3 plus 4 would be 7. Okay, now let's look at fg of x. See? Now, this is multiplying, and it's just like you would think. Judging from what, using what we've done so far, that just means multiply these functions together. F of x times g of x. So 2x plus 3 times 5x minus 4, and you multiply these out, distributing each term in this function by each term in this one, or FOIL, however you want to look at it, and you get 10x squared plus 7x minus 12. Now, we also have f over g of x. So that's just f of x over g of x. Now, when you have this, we have a fraction here. And usually in a situation like this, we need to at least think about what the domain would be. Because with these others, the domain is just all real numbers. We can plug in anything in here for x. But here, we have to be careful. So remember, with domains, what we want to do is, when we have a fraction like this, we want to set the denominator equal to 0 and determine what will make that denominator 0. And in this case, we determine that we better never let x be 4/5, because if x is 4/5, that will give us a 0 in the denominator, and this would be undefined. Now, we could write that in interval notation this way. Okay, now let's suppose that instead of saying f plus g of x, we actually have a value, f plus g of 3. Well, no difference really, except we'll actually be able to come up with a number instead of an algebraic expression. So f of 3, see, I plug in a 3 here and get 6, 7, 8, 9. That would be 9. Plug in a 3 here, and I get 11, 15 minus 4. So this is 9 plus 11, which would be a 20. Now, we could do the same thing, f minus g of 3. Well, that would be f of 3 minus g of 3, or 9 minus 11, which would be negative 2. We could do the multiplying, f times g of 3, 9 times 11, see? 9 times 11 right here, it would be 99. And of course, we can do the quotient, f of 3 over g of 3, and that would be 9/11. And I'll just leave it there. I won't convert that to a decimal or anything. Okay, so that's how we can deal. That's when we talk about combinations of functions. Those are some of the types of problems that we would need to address. Now, there's also composition of functions. So we have two functions here, and let's look at a composition. The notation would look like this. Notice it kind of looks like fog, right? F of g of x. That's the way that's read. F of g of x. Now, what that really means is this function, this f, is the outside, and what we're going to do is we're going to plug in the g of x. So it's f of g of x. These mean the same thing. So how would we evaluate this? Well, we take the 2x plus 3, except notice I left a blank there where the x was. And I'm going to put in the 5x minus 4. See, I'm going to put in the g function right there. There it is, 5x minus 4. And then just use a little bit of basic algebra. That would be 10x minus 8 plus 3. So 10x minus 5. Yeah. Now we could go the other way. We could say, well, what about g of f of x? Well, now the outside function is g. So I'm going to proceed the same way. Rewrite this g function, 5x minus 4, but leave a blank there where the x is. And put in the 2x plus 3. See, 2x plus 3, I just put in the f function. Now that's going to be 10x plus 15 minus 4, or 10x plus 11. Now we could also put in numbers in here. See, f of g of 3. Now, I could just put the 3 in up here because we've already found that f of g of x is 10x minus 5. And that would be, put in the 3 here, and that would be 30 minus 5. But let me go ahead and do it the long way. We have 2 times 11 because g of 3 is 11. See, so I put in 11 right there. 2 times 11 plus 3. See, what I'm doing is I'm finding g of 3 from here. I'm taking that result and putting it over here for the f. See? So g of 3 is 11. So 2 times 11 plus 3, and that would be 22 plus 3 is 25. And notice that's the same thing as if I plugged in up here where I found f of g of x. In other words, I found generally for a given value of x, f of g of x, what is that? Well, there we have it. Now let's go the other way, g of f of 3. That would be g of f of 3. F of 3 is 9. So this would be 5x minus 4. That would be 5 times 9 minus 4. 5 times 9 minus 4, which would be 41. Okay, now this is composition of functions. Now, sometimes you'll see problems where you need to use graphs to find composition of functions. So let's suppose I've got a graph of f right here. And I've got a graph of g right here. And we want to find f of g of 3. Now this is a different f function and a g function than what we previously were using. This is just, I'm just using f and g. This is brand new function f, brand new function g. And we want to find f of g of 3. Well, what that means is find g of 3 and put that result in and find f. Now look, g of 3, if you come over here to g of 3, and you come up here, you find g of 3 is 5. So really what we're trying to do is we're trying to find f of 5. Now let's go over here. F of 5 is 2. So that's going to be our answer. But there's our function, 3 comma 5, and then 5 comma 2. So the answer is 2. You can see that. Now we can go this way. We can say g of f of negative 4. Well, first thing we do is say, okay, that means g of f of negative 4. So I need to find f of negative 4. Ah, there it is, 3. So what I'm going to do is I'm going to put a 3 in here and find g of 3. Now we already found g of 3 is 5. See, over here? We already found that. Okay, so there's that, and there's our 5. And that's the way, that's the story with composition of functions.